3-7, and we're in heaven because that means after this one, we only have two more sections left in chapter 3. Very long chapter, I know, but there's just so many different variations of these things we call derivative. The next one on the docket, inverse functions. So this isn't one that we'll use often. It's going to be another short overview. I will do a little bit of derivations, and I even skipped one of the theorems in the book that they use. It's not one that we'll even use very often at all or see. So I skipped it. If you want to check it out, go look at it in their book. Otherwise, we're going to start off with x to a rational power, like 1 over n or m over n. And is this anything different than our power rule, x to a power? No. So go ahead and fill these in carefully. We will come across things that have these rational or fractional exponents. The good thing is the rule is still the same for our power rule. You should have come up with 1 over n. You would bring that power down in front and then subtract 1 to that exponent, which means you're going to have a common denominator and go from there. So if you wanted to, you could write this as n over n and this one as well because of the denominator. Right? Otherwise, still our same old power rule. But because we're talking about inverse functions, there are trig functions that we will come across, not so much in this class, but definitely in future courses, namely second semester calc. So what I'm going to ask you all to do is try to come up with at least this first one, and then I'll just give you the rest. Again, something that we can memorize. Don't stress too much about these. I'd rather you know the derivatives of the 6 trig functions, not their inverse. If we see these, we'll look them up. And in reality, what these actually are what you're just going to have to kind of recognize. Hey, I remember seeing those. I think then I can rewrite it like this. Or if we're asked to find the derivative, look them up, label these. Let's do this first one together because we actually don't have the tools necessary to find this unless you looked it up, went out on your own. More power to you. Let's pretend that what we had here was our equation or function. So that means we have, and remember with trig functions, when it's the inverse or reverse, that means that the input and output have been reversed. So since I do not like this, I'm going to go ahead and do the inverse and actually flip-flop spots for my input and output, which would now look like, and if you recall that whenever you have a trig function, what always has to follow it, unless it says inverse, which means they've reversed the input and the output, what always follows a trig function is the angle. So this is my angle, and therefore this is the ratio. So I'm going to go ahead and make sure that you see the ratio by putting it over 1. And then I'm going to draw this scenario out where I have my right triangle for my angle y. For sine, we know is the opposite over hypotenuse, or y over r. So I can label that as, which means we are on the unit circle. And because it's a right triangle, we can use the Pythagorean theorem to find this third side, which I'm not going to go through that. You guys can do that on your own, but it's just this squared plus this squared equals my hypotenuse squared. And then I'd subtract this to that side to find my unknown, which would be, and now I quote unquote know all 3 sides. But don't forget, we're trying to find the derivative for this function, which we rewrote in this form with respect to x. So my next step would be to do just that and take the derivative with respect to x for both sides of my equation. And when we take the derivative of x with respect to x, you can see I got dx over dx, which is just 1. And this is where you got to be careful. This is a chain rule. This part on the right here, I have sine of something, another function. So to take the derivative, we'll do the outside first, and the derivative of sine is cosine of our thing. And then we would have to take the derivative of the inside function, which would be actually what we were trying to find. the derivative of our function. So all we got to do is isolate or solve our equation for that by simply undoing the multiplication by dividing both sides by that cosine of y. Now I have my dy dx, and I can see that it's equal to 1 over the cosine of y. And because we have a triangle with cosine of y in it, we can come up with the answer or result that yields my derivative, which would be that. The cosine of my angle is the adjacent over hypotenuse, or just that. So that, my friends, is the derivative of the inverse sine function. It's 1 over the square root of 1 minus x squared. A little different than what you probably expected. Yeah, no trig function, actually. So if you wanted to do something similar with these, you definitely could. But for now, I'm just going to give you the remainder, and here they are. And as you hopefully notice, cosine, as we know, is just the derivative that is negative of sine. So it is just negative of whatever the sine was. And because we know tangent is just sine over cosine, we could have just simplified that and gotten this as the result. As far as cotangent goes, negative of tangent, and secant and cosecant, you can see all the co-functions have the negatives. All right, so again, pretty nasty. We will not see a lot of these in this course, but it is something that you will see and utilize in second semester on through. So now that you've seen those, put them in your memory, write them down, have them as notes to utilize later on down the road. But for now, let's keep pushing forward with derivatives in 3.8. See you there.